In the second part of scene nodes chapters, we will have look on distribution, color operator, material operator, random selection and fields. If you would like to work with scene nodes in your custom layout, go to the window menu, and here you can find and activate scene node editor. If you are working with heavy geometry or high count of distributions, for better computer performance, you have control over 3D viewport display. Here you can choose display mode, which can significantly help with computer performance. In this example, I will use primitive operator and I will connect it into the scene. If I would like to change display mode, I have to click on empty space in scene node editor and I will have access to display mode again. So as next step, I will change display mode from slower full shading to faster basic shading mode. And now if I will work with scene nodes, they will have faster response in 3D viewport. As next step, I will change primitive from cube to sphere. And I will increase sphere segments for smoother looking result. As next step, I will use distribution operator. And because both nodes are from operators category, as I explained already in previous chapter, I will connect their operator ports. As next step, I will connect distribution operator output into the scene. And as you can see in 3D viewport now, distribution operator using similar workflow like cloner. Result depends on distribution type, so if I will use as example radial type of distribution, I will have control over distribution count, radius or align, exactly as you know from old school cloner. As next step, I would like to change object's color. So I will use color operator. Again, I have to connect operator ports together. And if I would like to see result in 3D viewport, I have to connect color operator into the scene. Now I have control over object's color. By default, it's black color. In parameter section, I can choose any color what I like. And as you can see, chosen color will appear immediately in 3D viewport as well. As next step, I will make a little bit more space for more nodes. And I will show you another trick, which I'm using very often. As you can see, color operator node has operator input, but color input as well. These kind of ports are very useful, especially if I am able to extract data from other nodes and use them for this input. Distribution operator is definitely one of the nodes which contains data which we are able to use for color input. So as next step, I will click on distribution operator output sign to get access to all his outputs. As you can see, this output contains two different colors. Blue color, which we see mostly if we are working with geometry-based nodes, and white color. So as you can see again, this color language is very helpful. In this case, I will use ratio output and I will connect it into the color input of color operator node. And as you can see in 3D viewport, now we have totally different result because currently color input data control colors of all objects. And because I used ratio data, every single sphere has different grayscale value. Grayscale data are very useful because I can recolorize them with the RAM node exactly as I need. I have two options how to do it. I can either use RAM node inside scene node editor, or if I would like to have even more control, I can do it later in shader graph of applied material. My favorite renderer is Redshift, so I will show you now step by step how scene nodes work together with Redshift. So as next step, I have to use material operator. Again, I have to connect together operator ports, and also I have to connect material operator output into the scene. Material operator is able to work with physical render, Octane or Redshift. Only what you have to do is drag and drop material into the material field. So as next step, I will create standard Redshift material. Now I have to select material operator node, and as next step, I will drag and drop Redshift material into the material field. Now is Redshift able to communicate with C-Node's editor and read all important data as well. As next step, I will go to Redshift menu and I will open Redshift Render View. If I will activate Redshift Render View, I will be able to see current result from C-Node's editor inside Render View. Also, I have control over Redshift material, so I will make a little bit more space, and I can open Redshift shader graph as well. So now we will work for a while in Redshift shader graph instead C-Node editor. Inside Redshift shader graph, I can control materials parameters exactly as I need. For better demonstration, I will decrease reflection contribution. As next step, I will need color user data node. Color user data node, for this example, I will connect into the diffuse color. As you can see in render view, I am not able to see any result yet, because I have to specify what attribute I would like to use. So as next step, I have to select color user data node, and I have to choose proper attribute. And because I would like to read color data applied on objects in C-Node editor, I will choose in object section, object color attribute. As next step, I have to restart Redshift render view, and now I am able to see correct result. So as next step, I will use ramp node. Output from color user data node, I will connect into the ramp node input, and output from ramp node, I will connect into the diffuse color. Now I am able to colorize grayscale values exactly as I need. As example, I will use some ramp's color preset, and as you can see in render view, ramp colors are applied now on C-Node's objects. If I will try different preset, I will have different looking result. If you have difficulties to understand Redshift materials, check out link in the video description about our Redshift course, where you can find out all details about rendering, shading and lighting using Redshift. So as you can see, I use just few nodes inside shader graph, and Redshift is able to process all data coming from color operator node. And because entire setup is fully procedural, now I can change any parameter inside shader graph or inside C-Node editor, such as distribution count or radius, and I am able immediately to see correct result in the Redshift render view. That's a huge advantage of fully procedural workflow, because I can anytime change parameters or object type, and I do not need to rebuild entire asset again and again. Shading needs also lighting, so as next step I will go into the Redshift menu, and as example I will use dome light. As you can see, dome light or any other Redshift lights correctly affecting created scene. So all lights or any other Redshift objects you will find in object section, and in parameter section you can control all their parameters. Now I have control over background visibility or exposure intensity, or I can choose which HDRI map I would like to use. As next step, I will use Redshift standard camera. Again, I can find this camera in object section. And if I will activate this camera, I can control Redshift camera manually, directly in 3D viewport, exactly as works standard C4D workflow without seeing nodes. In this example, I will show you how to work with imported geometry. This time I will create sphere from main UI. So instead to have sphere inside C-Node editor, I have sphere in object section. As next step, I will change sphere radius, and I will increase sphere segments as well. As next step, I will use deformer, again from main UI, and as example, I will use my favorite deformer, displacer. And I would like to use displacer to deform sphere, so I have to create proper hierarchy. As next step, I have to choose which shader will drive displacer. So I will choose noise shader. Now I can choose what kind of noise I would like to use. And also I have full control over all his parameters. So I can change seed, or noise scale, low clip, and high clip value. So until now we are just creating standard old school setup without using C nodes. For better looking result, I will increase sphere segments. And as next step, I will use also subdivision surface from main UI to create example which will use multiple tools and little bit more complex hierarchy. In display section, I can choose mode, how I would like to see it in 3D viewport. I will keep higher amount of polygons for this example because I would like to see how high amount of polygons will work with C-Node setup. If I would like to use standard objects or imported objects from object section inside the C-Nodes editor, I have to use node which will be able to process and import all this data into the C-Nodes workflow. So as next step, I will go into the C-Nodes asset search and I will write import. As you can see, under info category is legacy object import. So remember that if you would like to work with geometry, which is located in object section, use legacy object import node. Legacy object import node contains object field. So as next step, I have to drag and drop object which I would like to use inside C-Node editor. So I will drag subdivision surface because it's highest in the object hierarchy, and I will drop this entire object into the object field. As next step, I have to click on Update Parameters Ports. And now as you can see in C-Node editor, I have access into the all objects ports on geometry level. It means this object is not operator yet. So as next step, I will go into the operators category and I will use geometry operator node. As we know already, I have to connect together geometry ports. And now I am able to preview this imported object into the 3D viewport. But remember that in 3D viewport are also visible objects from object section. As next step, I will hide geometry and tools from object section. And now I can see how looks the result from Scene Nodes editor only. But still I have to keep all objects inside object section as well, because legacy object import node referencing all this data. As next step, I will use matrix operator node. And we know already how to correctly connect together two operator nodes. Now I have control over object's position, scale, and rotation. As next step, I will change Scene Node's display mode. So I have to click on empty space, and I will use basic shading for faster computer performance. I would like to use current object for distribution around the primitive object. So as next step, I will need distribution operator. In distribution operator parameters, I can choose from many distribution types. And as you can see, here are also new distribution types, which doesn't contain cloner. But what is more important? Distribution type contains also edge, polygon, and vertex type, which needs geometry data for correct result. So as example, if I will choose linear distribution type, I can see different input ports, then has edge, polygon, and vertex distribution type. For better demonstration, I will connect matrix operator with distribution operator. And now we are able to see result in 3D viewport. Imported object is too large, so as next step I will change object scale in matrix operator. Now I can see much better how works linear distribution of imported object. For more interesting or even random result, I can control also distribution inputs, but this example I will show you in different chapter. As next step, I will change distribution type from linear to mandelbrot, and now to mandelbulb. And as you can see, every single type of distribution has slightly different parameters and contains some different input ports as well. And in case that I would like to use edge, polygon or vertex distribution, as I mentioned already, I will need one more step for correct result. So as example, I will use polygon center distribution. And as you can see, this type of distribution needs geometry for proper result. So as next step, I will go into the geometry category. And as example, I will use torus. But of course, you can use any other type of primitive or even another imported object. As next step, I will connect torus geometry output with geometry input of distribution operator. And as you can see in 3D viewport, torus geometry controls how we look distribution of imported object. So it's similar workflow as using cloner with object mode. And because it's procedural setup, I can change now torus parameters, distribution type, or I can use also randomization and color mapping. All depends on creativity and scene purpose. In this example, we will have look on noise or random selection. In object section, you can see imported dragon model. As I explained already in previous example, if I would like to use models from object section inside scene nodes editor, I have to use legacy object import node. As next step, I will drag and drop dragon model into the object field, and I will activate update parameter ports. As next step, I will use as example extrude node. Geometry output of imported object, I will connect with geometry input of extrude node. As next step, I need geometry operator. Geometry output from extrude node, I will connect into the geometry input of geometry operator. All these steps we know already from previous chapter. So if you are not able to understand and follow current steps, please check out previous chapter. If I will connect geometry operator into the scene, I can immediately see how looks extruded geometry on imported object. But currently is dragon model visible twice. One from object section and second from scene nodes workflow. Manually in 3D viewport we can change position, scale or rotation only to objects which are in object section. And as you can see, now I am changing position of original object, but I am not affecting scene nodes result. So if you need, you can use combination of these two workflows. But if you need original object just for import into the scene nodes workflow, hide this object from 3D viewport and render. As next step, I would like to change extrude parameters. I will decrease offset parameter and I will increase amount of offset variation. But as you can see in 3D viewport, still it produces very uniform looking result. Nodes for editing geometry such as bevel, extrude or subdivide contains also selection input. So if I will write into the asset search field selection, as you can see in geometry category are many selection nodes such as grow selection, remove selection, random selection or noise selection. As example, I will use noise selection node. Noise selection node contains selection output. And that's exactly what we need if we would like to control selection input of extrude node. So as next step, I will connect together both selection ports. But noise selection node needs also geometry information. Without geometry data is not able to create any selection. So as next step, I will connect geometry output of imported object with geometry input of noise selection. And as you can see in 3D viewport, noise selection helps to break up extrude uniformity because noise controls which polygons will be extruded or not. As next step, I can change noise type or parameters. As example, I will use electric noise. And as you can see, threshold parameter strongly affecting final result. Important is also scale parameter. And if I need, I can manually increase scale parameter as well. Maxon has very powerful noise types. And if you will try few of them, you can easily get interesting looking results. In this example, we will have look on C nodes fields. From operators category, I will use primitive operator node, and this time as primitive type, I will choose pyramid. As next step, I will connect primitive operator into the scene. And in display menu, I will choose quick shading with lines for better polygon visualization. If I will increase amount of segments now, I will be able to see amount of polygons in 3D viewport. As next step, I will use effector operator, and I will connect operator output from pyramid into the effector operator input, and output from effector operator into the scene. Effector type, as example, I will choose bulge. Transform mode, I have to switch to mesh. Now I have control over bulge strength and blend factor. As you can see, effector operator can be controlled by field. So as next step, I will use field operator node. Up output from field operator, I will connect into the field input of effector operator. As next step, I have to choose field type. So as example, I will choose spherical field. And as you can see in 3D viewport now, field operator controls areas where will be visible bulge effect. If I need, I can decrease or increase field size in parameter section. As next step, I will use matrix operator. If I will correctly connect matrix operator with field operator, I will have control over field's position, rotation and scale. In this case, I have to connect matrix operator output into the field's operator input. And now matrix operator controls position of spherical field. So as example, if I will change position in y-axis, as you can see in 3D viewport, all works properly. So now you get an idea how to use C nodes.